Hi everyone, I am George. I solve multimedia problems on Linux systems. I work for Collabora, and I'm known for my work around GStreamer, PipeWire, where I maintain WirePlumber, the session manager. And recently I've started also digging into BlueZ, which is what I'm going to talk about in this presentation. So in this presentation, I'm going to talk about Bluetooth audio. And first, I'm going to go through a little bit of history, talk about Bluetooth classic audio, what we had until now. And then I'm going to go into Bluetooth low energy audio, or LE audio, the new Bluetooth audio standard, and explain a little bit what's going on there. And finally, I'm going to talk about how to get LE audio on Linux. So let's start with classic audio. Before I dive in and start explaining the history, I want to clarify a little bit the terminology that I'm going to use. I don't know if you're familiar already with Bluetooth. Bluetooth is basically a set of specifications, and it is divided into two categories. There is the core specification, which defines the basic building blocks, like the radio parts and the basic abstractions to enable the communication between devices, the low layer protocols and features. And then we have the profile specifications, which define functionality that builds on top of the core. So the audio stuff basically are profiles. They build on top of the core. They are not essential functionality to get Bluetooth working. They're just optional features that you can add on. They target specific use cases, and they are mostly high-level protocols on top of core. And when we are talking about versions, when we say, let's say, Bluetooth 1, Bluetooth 2, Bluetooth 5, or 5.4 or something, we're basically referring to the version of the core specification, while the profile specifications have their own versioning scheme, even though they are being released together with some update to the core. So we might see, let's say, HFP 1.9 was released together with Core 5.2, I think, or something like that. So they get released together, but they have separate versioning scheme. So with that in mind, let's dive in. Bluetooth audio, where did it come from? Like, what is Bluetooth anyway? How did this start? So the idea came from the late 80s, where people were trying to find a way to replace serial data cables with something that would be wireless. And initially, the idea, I think, was for accessories like your keyboard or things like that. Yeah, it started being developed by Ericsson, which was a mobile phone company. So they focused a lot on the mobile phone use cases. And the first release was in 1999. And it had no audio in that release, even though audio was being worked on, it was planned. But it was the first version was make the basics work. But very soon after, in 2001, we had the first introduction of Bluetooth audio with the HSP and HFP profiles. HSP stands for headset profile, and HFP stands for hands-free profile. They are very similar things, because a headset and a hands-free are very similar devices, and they look alike very much. I'll explain the differences in the next slide. They are both used for bidirectional audio transfer, which is meant for phone calls, so voice data. And underneath, they use something called the synchronous connection-oriented transport, which is a transport mechanism in Bluetooth, which is exclusively used for these profiles. It's not used anywhere else, which allows a steady transmission rate from one device to the other. And if you know Bluetooth basically uses time division, multiplexing. So there are time slots. So the bandwidth is like divided in time slots. And what the SCO transport achieves is that it gives you some reserved time slots which are meant for these audio data. So you have a steady connection because you have reserved time slots that are not going to be taken by something else. But at the same time, you have capped bandwidth. You cannot exceed the reserved slots in terms of bandwidth. So that gives restrictions as well. It is good for voice, but it doesn't scale after that. So differences, HSP is basically a more basic profile. It was meant only for headsets which didn't have a complex functionality. It was just some earpiece. And it had the ability to do some basic control functionality, like answering a call or hanging up or volume control. And these are pretty much all the actions you can do using a narrowband codec. While the HFP profile meant for hands-free, and I think it was mostly meant for, and it's still used in cars, where you want to do more advanced functionality, you want to have more control. And it has evolved to support a lot of features, actually. So you can dial a number, hold, do three-way calls. You can voice activate your assistant, like the voice assistant in your phone and things like that. And it also supports. It has gained support for more codecs much later. So in 2013 there was the support for the wideband MSBC codec, and in 2023 we also got the LC3 super wideband codec, which is much better. Now the control signals for HSP and HFP are 80 commands over an RF-COM channel. 80 commands are the text commands that have been used in telecommunications since 1981 to control modems, and they just carried on to use 80 commands, and there have been a lot of extensions and a lot of new commands invented, even vendor-specific commands, and they do all sorts of things, but it's all 80 protocol over a serial port, a serial over Bluetooth port. Then in 2003, much shortly after, 2 years later, after HSP and HFP, we got the Advanced Audio Distribution Profile, or A2DP in short, which is meant for high-quality audio streaming, so CD-quality audio almost, but only in one direction. So that was meant for like sending something to speakers, but not receiving on the other side. And the same year we got improvements for SCO with the extended SCO, and just a year later in Bluetooth 2 we also got the audio-video remote control profile, which allows doing media player controls like next, previews, or play, pause, and volume up, volume down, things like that. As I said, A2DP was meant for media playback, just media playback, and being controlled with the AVRCP profile to start the media player, to stop it, etc. And underneath it uses AVDTP, which is the audio-video distribution transport protocol, which is, in practice, it's RTP over Bluetooth. So because it's RTP, it can encapsulate many different codecs, as long as the bandwidth allows it, because Bluetooth has a limited bandwidth, or Bluetooth Classic has a limited bandwidth, let's say it that way. And today we have a couple of codecs that you can use. The basic one is the SBC, which is the first one and the only that is mandatory by the spec. And then a lot of companies have added additional ones like AAC, Aptix, LDAC, Opus, and some others. And it's extensible in general, so some companies invent their own codecs and they put that on top of A2DP. And yeah, it goes like that. Now, some issues with that. The A2DP is unidirectional only, and so high-quality audio can only be transferred in one direction. You can never get it back. There are some non-standard solutions for bidirectional audio, but very few implement them. And so in practice, they are not used. They can't be used. They can't be relied upon. So when you have a headset and you have a microphone on the headset and you want to just start speaking, so the microphone becomes active, the device, in order to send the audio back, it has to switch to the HFP profile. And that kind of sounds terrible. If you're hearing music and you want to speak and it switches, it becomes really, really bad, because then you get the, well, in the best case, you will get the LC3 super wideband codec, which is pretty decent. But in most cases, you will get MSBC or even CVSD in the worst case. And even though the, let's say the LC3 super wideband is actually a good, relatively good codec, it will still sound bad because the headset thinks that you're in voice mode. So it has a DSP inside, and it will start optimizing the audio for voice. And depending on the headset, you might have different results. So it doesn't depend exclusively on the codec, but it's also because the headset thinks you are in a voice call and tries to optimize for that. Classic audio also has high latency. A2DP has about 100 to 200 milliseconds latency. In HFP, it's lower. It's up to 40, I think, but still not good. And looking at today's use cases, things that are actually there on the market. So we have earbuds, which are two devices, coordinated devices. They both get the same audio, but they are two devices, essentially. We have things like spatial audio, sharing audio. So some vendors do audio sharing. You can have your headset and somebody else's headset both get audio from the same phone or laptop. That's a use case. And yeah, there is a vendor-specific thing that can be used in Bluetooth Classic. Voice assistants, where you activate your voice assistant and you talk to it, and basically that's implemented nowadays over HFP. So basically, if you look at what's going on under the hood in HFP, you are making a phone call to the voice assistant. That's how it's represented. Hearing aids and many more. And speaking about hearing aids have been a case where Bluetooth Classic didn't really work, because hearing aids need a long battery life. Somebody with a hearing impairment, he needs to wear the hearing aids for the entire day and take them off in the evening. And Bluetooth Classic, or if you do Bluetooth Classic audio, most headsets can do like 4, 5, 6 hours, something like that, 8 hours. They can't go for all day. And you need low latency as well if you want to do more interesting things with the phone on the side, helping you. So there are two non-standard solutions for that. There is the Google's audio streaming for hearing aids protocol, or ASHA, which was released as an open spec by Google, but it's not part of the Bluetooth specification, so it's a non-standard solution. And Apple's made for iPhone extensions, which are proprietary. And they are both based on the Bluetooth Low Energy stack, which I'm going to talk about soon, but they are not LE audio. They were both developed before LE audio. So let's look at LE audio, the future. So Bluetooth 5.2 in 2020 was the first version of the core specification to actually come with the extra set of profiles that make up the LE audio stack. And I say they are based on the Bluetooth Low Energy stack. Now, I need to explain here that the Bluetooth Low Energy stack is a entirely different wireless communication stack than the Bluetooth Classic one, which is often called BR-EDR, means basic rate, enhanced data rate. That's the classic one, and you have the low energy one, which are two different wireless communication stacks. And they're so different as if you're saying, here's Wi-Fi and here's Bluetooth. They're two different things. They just happen to run inside the same controller. Just like other wireless protocols will run inside the same controller, so it's very often you will see that one controller can do Wi-Fi, Bluetooth Classic, Bluetooth LE, Thread, Zigbee, and things like that. This new stack has the advantage that it's low energy. It has much lower energy consumption, so that's where its name comes from. It's a low energy stack. And LE Audio runs on top of that, so it has much lower energy usage. And it has also much lower latency, thanks to some good engineering. So it goes down to 20 milliseconds, and I think there is some discussion to even go beyond, like lower than that. Now, LE Audio is not one profile, unlike the previous ones. It's a collection of profiles that make up an audio framework, let's say, something which is modular and extensible. And it looks like that. So yeah. So the actual audio transport, so all of these are profiles. Like LC3 is a codec, never mind that, but all of these other things are profiles. So the basic thing here is the basic audio profile, which is the profile that defines how audio is transferred over Bluetooth. And it is the only profile that specifies how audio is transferred, so audio streams and things like that. And all use cases make use of that, unlike what we had in Bluetooth Classic, where we were switching profiles. Here we only have one profile. And it comes with helpers. So we have the published audio capabilities service, which defines some capabilities, stream control service, and then we have broadcast, which I will talk about in a minute. And this profile only defines streaming. It doesn't define control. So for control, we have all of these other profiles here. We have the volume control profile, which defines volume controls for outputs, basically. We have the microphone control profile, which is a single option, mute and unmute for your microphone, if your device has a microphone. We have the coordinated set identification profile, which is used to figure out what's going on with coordinated devices. Coordinated devices are basically the earbuds use case, where there are two devices, but they need to coordinate and they need to go together. The call control profile, which replaces the HFP controls, so you can do things like dial a number, answer phone calls, and things like that. And the media control profile, which replaces AVRCP, which is like play, pause, next song, etc. And the common audio profile is more like a unification. It defines how to use all of these underlying profiles together. That's what it does. And then we have higher level use cases, which are again like wrapping around all these things and trying to make it like more abstractive. And so we have the telephony and media audio profile. That means that if you have this, it means your device can play media and it can do phone calls as well. It's telephony and media. So this is the typical thing that you would have on headphones. Then we have the hearing access profile, which is for hearing aids. Hearing aids will implement that one, not the other one. And we have also, finally, the public broadcast profile, which is a new feature. So in Bluetooth LE Audio, we have this interesting new feature where we can broadcast audio to multiple receivers and also receive broadcast audio if we're on the other end. And that's a feature that is marketed as Auracast by the Bluetooth SIG. And it enables a couple of new interesting use cases that we didn't have before. At the very core, we have the low complexity communication codec, or LC3 in short, which is a new codec developed just for this new system for LE Audio. But it has been, let's say, quote, quote, backported to the HFP and A2DP profiles. So HFP got the LC3 super wideband, which is a tuned version of LC3 that takes up less bandwidth, but it can do better things than MSBC that was there before. And there is also LC3 Plus for A2DP, which is a proprietary codec. You have to license it to use it. But it's basically, again, tuned LC3 for the A2DP constraints. And for transport, they use something called isochronous streams. These are much more complex than the SCO that we had before for HFP, but they kind of achieve similar things. So they are time synchronized audio streams. So when you have, they're particularly important for Auracast. When you have multiple receivers, you have to somehow be sure that they will render the audio at the same time, because they could be speakers that you want to synchronize in your room, wireless speakers using Bluetooth LE audio, and you want them to play at the same time. So that's achieved with isochronous streams. You might come across the terminality Cs and Bs. That's the connected isochronous streams, is the unicast streams, basically, and the broadcast are the broadcast. Now let's talk about Linux, LE audio on Linux. So Linux has BlueZ, that's the default Linux Bluetooth host stack. I'm saying host because the Bluetooth stack is divided always in two parts. There is the host stack that runs on your SoC, and there is the controller stack, which runs in the controller. BlueZ consists of two parts as well. It has the kernel drivers, which take control of the controller, and then we have the user space daemons, the BlueZ daemon, and some tools. And for audio, we have PipeWire. That's the default audio server nowadays. And it has a plugin to implement access to Bluetooth audio devices, and it implements all the profiles that are related to audio. It does all the encoding, decoding, and transport to the sound card or wherever you want to route this audio. It has really, really good Bluetooth support. It implements all the known profiles today. So A2DP with a lot of codecs, like all the available codecs that we could implement, they are there. It implements HSP, HFP for all kinds of directions. So you could use PipeWire to implement, let's say, the gateway part, which is your phone, or you could use it to implement the hands-free part, which is like your car or your headset. It can do both roles. It also implements ASHA, the non-standard hearing aids profile. It can do LE MIDI as well, which is a profile for talking to MIDI devices like digital pianos and such. That's, of course, not an audio profile per se, but it's related, and it's interesting that we can combine that. And it also supports LE audio. So let's look at LE audio. Obviously, by saying it supports LE audio, it means it supports the basic audio profile. That's the thing that it needs to support, after all. Everything else is just control profiles. And they are not something that PipeWire needs to care about. They are more things that BlueZ has to care about and the applications that make use of them. PipeWire only needs to care about BAP, essentially. And it has support for all the roles here, so both unicast, sync and source, and broadcast sync and source. In addition, it handles the volume control profile in coordination with BlueZ, so when there is a volume control change, it can be reflected in the PipeWire graph and vice versa. We have support for coordinated device sets like earbuds, where earbuds will appear as two devices. They are two devices. And what happens is, because the BlueZ knows that they are a coordinated set, it will set some property, and that property propagates all the way to WirePlumber, and WirePlumber will set up a combined sync to basically to present them as one device, but then it routes the audio, it splits the audio and routes it to both devices. And There is also control for broadcast, because to create a broadcast stream, you need somehow to specify like the advertisement of it. What is the stream? What is it named? What are the properties that it has? Because the use case for broadcast streams is that if you have a source somewhere and you want to connect to it, it's going to work like the Wi-Fi access points where there is a QR code somewhere and you go and scan that QR code with your phone, or alternatively you list, there is a list in your phone where you can see the broadcast sources, and just like you can see the Wi-Fi access points, and you can select one and it will have a description and say this is for that purpose. So that kind of stuff needs to be configured, and it's available through a WirePlumber config. Now, it's not pretty. We need somehow to make it dynamic. We're discussing how to actually make it more dynamic and not have it in the WirePlumber config, because it needs to change at runtime. And if you're interested in more details, there is this wiki page on the PipeWire wiki, LE audio and LC3 support, where it has, we try to keep it up to date with the latest status and information about what's going on, what is supported, what is not, and what you need to do to get it to work. Now, I will try to go through what you need to get it to work here. So, requirements. First of all, disclaimer, LE Audio and Auracast is still work in progress. There are some rough edges. Don't expect it to be magical and work like completely seamlessly yet. Many things will work just fine, but it might not be trivial to set them up, or you might see some bugs. So what you need is the latest Linux kernel. I have an asterisk there in both words, latest, because actually what you need is Linux 6.4, which is not really the latest. It's like 2 years old. But there have been many, many fixes since 6.4, so the latest, the better. The later, the better. But the latest stable is also fine. It has support. Same goes for BlueZ and PipeWire. So the later, the better, because we are still working on the stuff, but the latest stable is also fine. If you want to make sure, basically, when you compile PipeWire, or if you're getting it from your distribution, you need to make sure that it has been compiled with liblc3 support, so that it has the codec, because that's what controls the entire LE audio stack to be compiled. And then you need a Bluetooth adapter that supports LE audio. Now, it's a bit unclear sometimes which controllers support that. And recent Intel controllers are known to be very good on that. So the BE200 series is probably the best, because that supports also Auracast. The previous series, the AX110, I think, supports LE audio, but not Auracast, not the broadcast streams. Controllers from NXP, like the latest that they are actively selling, they are also working fine. And actually, NXP has contributed a lot of the code in BlueZ and PipeWire to make that stuff work. Some recent MediaTek controllers also work, and you might see them in the market also as AMD Bluetooth something, because there is AMD basically takes the chip and makes the cards that go into some laptops. Qualcomm controllers, many recent Qualcomm controllers also work. It's unclear. It's a little bit more unclear to me exactly which ones do what, because they need support in the firmware. They need support in the firmware, especially for Auracast, to be enabled. But yeah, many of them actually do support LE audio. And there are also the Nordic ones, which are more for more embedded use cases. They typically come with their own host stack that runs entirely in the microcontroller. These run as Zephyr image, by the way, and they have the entire stack running on there. But as far as I understand, you can also flash them with another Zephyr image that only implements the USB, controller so you can interact with it over USB and get the whole stack running on Linux instead. Now, if you have a controller and you want to check what it supports, go into Bluetooth control, menu management, and then type info. And that gives you the information of the controller. And if you see, you will see that it says, oh, here, sys central and sys peripheral. This is the support for LE audio unidirectional. That's the sys is the connected isochronous stream. And then you will see ISO broadcaster and sync receiver is the support for Auracast, for the broadcast streams. So if you see either of them, you can tell immediately. Like if it's supported in the controller, you will be able to see it here. Due to a bug, it's only shown in the current settings, not the supported settings, unfortunately. The Auracast one, actually. The sys is shown here, but there is a bug, and it doesn't show. Anyway, we'll fix that. Now, if you have a controller that shows these capabilities, how to get it to work. Go to etcbluetoothmain.conf and enable experimental features in BlueZ, and also enable kernel experimental and put the ISO socket UUID there. Now, the ISO socket UUID is something that you will find in the comment just right above that line. So just copy and paste it in the kernel experimental line. That enables the ISO socket, which is a kernel feature, which is still experimental in the kernel. It's about to become stable. There is some discussion to make it stable, but I don't think you will be running like the latest kernel from master. So for an older kernel, you need that. And in PipeWire, go to wireplumber conf.d and make a file bluetooth.conf or something. Or basically, actually, no. Actually, you don't need to do any of that. If you don't have any Bluetooth-specific configuration in wireplumber, it's going to work out of the box. So the idea with wireplumber config is that if you want the default options, like enable everything, you don't need to touch anything. But if you have a file that changes the BlueZ.roles, for example, then you need to make sure that the BlueZ.roles, which is an array of supported Bluetooth roles, needs to contain those roles, bap sync, bap source, bap broadcast sync, and bap broadcast source. This will enable things. If you need to look into the broadcast config, you can look into the man page of PipeWire props. There is an example there. It's not well documented. I myself don't understand half of it yet. So yeah, and that's going to change. Now, if you have enabled those options and you've got everything running, go into Bluetooth control again and type show this time, and that will show the active configuration. And in the active configuration, you should be able to see published audio capabilities. It means you have the unicast LE audio support. And then broadcast audio scan, it means you have the broadcast profile as well. And you should also be able to see experimental features, BlueZ experimental ISO socket, and this is the UUID of the ISO socket that you put in the configuration file. So that's how you verify that your configuration is correct. Then you need a peripheral, something else that will connect. So let's say you have an LE audio headset or another machine running BlueZ and PipeWire. As soon as you pair it, now Bluetooth control will change its prompt. It will show the device name. So you can go and say info, and then it will list the information of the device. And in the info, you should be able to see again published audio capabilities and broadcast audio scan. Broadcast is obviously optional if you're not looking to enable broadcast, but published audio capabilities is the basic one for the unicast. And then you see here there are some other profiles that are related to LE audio, like volume control, microphone control, audio stream control, common audio, telephony and media audio profiles. So all of these profiles are there. That means that your device is good. It has all the support that it needs. But always remember that here, in my case, I'm pairing the Galaxy Buds 3, which are earbuds, so they are two devices. And remember that they are two devices. So if you connect one of them, you actually, it's not going to work. You have to connect both of them. You have to scan, you have to list the other device, you have to pair and connect the other device as well, and make sure both are there in order to get something working. Now, problem is if you have a device that supports both classic and LE audio, what do you do? How do you switch between the two stacks? Unfortunately, this is not like we had before. Before we had, like in PipeWire, you could go and look at the profiles of the device, and it would say, oh, it supports HFP, it supports ATDP. So you had the drop-down box, and you could select which one to use. But here, we are not talking about a new profile. We are talking about an entirely different Bluetooth stack. And the problem is, if you connect the classic stack and the audio profiles from the classic stack, then the LE audio profiles are not connected, are not going to connect. So you need something to switch stacks. So that's what the bearer command comes. That's where the bearer command comes in. So you can go to Bluetooth control and type bearer LE on your device. You have to have your device connected first, and when it is connected, actually in the previous command, in the info command, you should be able to see somewhere below the profiles, it should say bearer something. And the default value is the last used bearer, which will connect to the last used bearer. But you can change, and you can connect LE, or you connect BR-EDR. And that will change the preferred stack for the next time. So after selecting the bearer, you need to disconnect, and then connect again. And as soon as you connect again, you will get the other stack working. Now, in BlueZ Master, which is to become 5.84, there is a new experimental dbus API and some more explicitly Bluetooth control information. So if you are in BlueZ Master or 584, when you type info, you will have explicit information about BR-EDR connected or LE connected and paired as well, because pairing is also different for each stack. You might have a device paired in classic mode, but not in LE mode. You need to pair it in both stacks. And also the change commands and all the status commands will show BR-EDR or LE, so it's going to be a little bit more obvious. And there is also the dbus the API that you can use to do it programmatically from your application. Obviously, this is a UX issue. How should users know that they need to do all this complex stuff, switch stacks, and make sure that the device that they have already paired in one stack actually needs to be paired in the other stack as well. It's a bit of a mess. And that's an active problem. That's something we need to work on. So in general, to-do list, improve that usability with improve the tools like we are trying to do with Bluetooth control, but we need to also improve the UI tools to support these use cases and probably implement some automation. So for example, when you want to switch from A2DP to LE audio, you won't have to manually go and disconnect and reconnect and do all of that. It will have to be done automatically. And on the UI side, we also need control for Auracast. So we need a way to list available broadcast devices and connect to them, and have a way to scan a QR code, for example, if you're a mobile device, and things like that. And it would also be nice to have a call UI. It's something in my to-do list. I would like to have a call UI so that we can test calls that are now implemented also for HFP in PipeWire. We are actively working on moving the HFP control bits from PipeWire into BlueZ so that we have an API in BlueZ that allows us to make calls and receive an answer and things like that, and make an abstraction so that the call control profile for LE audio can use the same API so that we don't have to implement two APIs. And it also helps with qualification. So we can do a call control profile, an HFP profile qualification without having to run PipeWire on the system that the qualification tests are running on. And LE Audio is still in active works. The Bluetooth SIG is actively working on new features. Some of them are already known to members, and they are coming. So that's because LE Audio is very modular. We're going to see more and more features, I think, in the coming years. So we need to work on making sure that they are supported in our site. If you want to contact us for BlueZ, go to for BlueZ we have a Slack channel. So go to bluez.org/contact. It's a really ugly website still, but we are working on improving it. And there is a Slack invitation there. Just click on it and you are in. There is a mailing list, Linux Bluetooth, where patches and discussions go. And there is a GitHub also repository where the code lives. And there is a CI now integrated with a mailing list. So when you send patches to the mailing list, it automatically creates a CI pipeline on GitHub and runs tests. And we also manage tickets there. For PipeWire, we are in Matrix, pipewirematrix.org, and we have a GitLab on the GitLab freedesktop.org instance where the code lives. And we have a mailing list, but don't use it. We don't use it. Everything goes to the GitLab issue tracker. So even if you want to discuss something, file a ticket, then there is a label to mark it as a discussion or as a question. Thank you very much.